Okay, good morning everyone. Hi, my name is Lloyd. I'm the presenter for this particular session. So this session today is on troubleshooting Windows internals when something goes wrong. All right. So let's start off. Basically, we'll talk about what is the various things that can go wrong. Okay. What are the various troubleshooting tools that you get? So I'll just like to highlight every tool that I'm going to talk about here is freely available, freely downloadable from Microsoft or from somebody who's actually written some stuff. Okay. And then I'll talk about what are the various areas that you look at things and see things going wrong or right. And then we'll talk about the major problem classifications. And then lastly, I'll talk about some case studies of various things that's happened in the past. And then at the end, I will do a XPerf trace. That means I'll actually show you guys the Windows Performance Analyzer and what happens, how we actually trace through performance issues where we see something going slow or whatever, and I'll go through and show you exactly how it all works. Right. So let me just start off by saying, what is the best troubleshooting tool out there? Any guys on anybody? Right. Some people will go, oh, it's perfmon, man, or else it's Windows Debugger, pullmon, or else, heck, just call Microsoft support. It's great. Now, I'd like to highlight the first important point. The most important troubleshooting tool is that thing up here. Okay? Please remember that. The tools that you get are not going to help you if you don't use this. All right? Because without that, nothing works. Okay? All right. So the first tool we have today is perfmon. Now, everybody knows about this one, right? Come on. You've all been playing with it. Now, what is the problem with perfmon? The first issue with it is that it's only reliable up to a single second. It cannot do millisecond responses. So it can't go inside 1 second and tell you what happened to it. It can only go all the way into second by second is the max. And in most cases, we don't actually record every second because it takes too much disk space. So we'll do something like 15 seconds, 30 seconds, 1 minute. All right? So you can use this to grab all the major stuff that we look for. And the other thing is you must not look at CPU, because the CPU is not accurate in a VM. And that includes Azure, by the way. All right? So what happens here is that whatever you read from the CPU is close to, but usually not exactly corresponding to what the real CPU usage is. Okay? So that's perfmon. Now, where is it great? You use the capture for a long period of time to see what went on in some systems, something that's going wrong maybe at 12 midnight or something. That's where you use it. Okay. The other stuff we talk about is resource monitor. So resource monitor is probably the most useful thing in your system when you look at things happening on the fly. The problem with resource monitor is that you can't save. So you can only see it on the fly. If it passes, you can't get back to it previously. You just lose all the information that was there. Now, there are a few things in there which are hard to get elsewhere. If you see where I've highlighted that line in terms of TCP connections, the reason why we highlighted that particular part is because that's one of the places where you can see your network having issues, which doesn't show up anywhere else in the system easily. Okay? One of the case studies we do, I'll talk about that at that particular part, right? Okay, so resource monitor, where do you get it? It's in your Windows machine, right? You don't have to install anything. On the bright side, it means that you don't have to go through change control to get it up and running. Just click RESMON, run it, and then you can see the whole thing in there. Okay. One other thing I want to highlight for resource monitor is that the graphs at the side there, they change the y-axis at every moment. So just because you see something green or something red all the way, it doesn't mean it's really that high. You have to look at the graph because the graph changes in scale. I'll show you later when we get to the case studies. All right. This is Windows Performance Analyzer. So this one is separate from Microsoft's Windows. You have to download it separately. It doesn't come in Windows itself. So usually we get it from things like the Windows ADK, the application deployment kit. Oh, sorry, I can't remember what is it called now. But the idea here is that you go download the ADK, then you can get one tiny MSI file or cap file that you can install. And then from there, you actually get the information that you want. Now, this thing is great for pinpointing short stuff, because nobody uses this thing to record a whole day. Yeah, you can if you want to, but that means this file is so big you'll never be able to analyze it. All right? We use it to record very short intervals of times. So usually 20 minutes, 30 minutes is the max I've ever seen for using this particular tool. All right? And you can see at the side here, I'll show you later, the left contains all the various classifications of various things. Then on the right, you show up all the graphs of everything you want to see. Okay? We'll run through this particular tool later in the session, and I'll go in depth into it and show you how you can actually get stuff happening. Right. So there are two parts to this tool. There's one called Windows Performance Recorder. The other one is called Windows Performance Analyzer. Now, it kind of explains self-explanatory what they mean. Recorder is the one you put on a machine that's having problems. It does not need to be internet connected. All right? The analyzer is the one that you put on a machine that you're going to analyze stuff on, and you should keep that internet connected, and you have to set up various things on it so that it automatically gets the correct symbols from Microsoft and all the various important stuff from Microsoft. So that way, it gives you the right information when you pull it up and look at stuff. Okay. Right. The last thing, of course, is that because this guy requires installation, you have to go through change control in most environments. And I always joke about this because if your machine is having trouble, there's no problem getting change permission for it. Trying to get it beforehand, on the other hand, is a bit of a problem because not every company will allow you to do it. All right. Okay, last one, Windows Debugger. So the Windows Debugger is used to actually tell you, hey, I got a crash dump, I want to see what happened to it, pull it out and look at the system. Now, again, same story here. Nobody I know has ever put this on a production box, unless the production box has been crashing like crazy, in which case you need to actually put it on to actually troubleshoot what's happening, all right? Okay, the usual case here is to get DMP files and then use the DMP files to actually manipulate and check stuff inside, all right? Please remember the setup symbols. So that's the link here that shows you how to do all of that. And again, I'll just show you a very short demo on this one. Okay, there's a new tool coming up, just came out a couple of months back, and this is done by one of my colleagues in Microsoft Israel. So for those guys who know about pullmon, so pullmon tells you who is actually using memory in your environment. So it used to be a command line version, and it's quite hard to extract because you got to go to a lot of places to actually grab it. So what he did was he actually built this whole thing, and it's now a nice self-contained executable that you can just run. And then automatically gives you all the pull information for that particular machine as you're running it. Okay, which is nice because it's great, and then you can actually do all the nice, beautiful colors and everything, which we never used to have. Okay, and the nice thing is you don't need to reboot to install it. So just take the executable and run it. Depending on your change control, you may not need to go to change control. Depends on your environment. Okay, but that's a great thing. All right. So the last tool I want to talk about is something called Driver Verifier. So this exists in every Windows machine currently. Considering 2003 and below is all out now. Okay, we no longer support them. So therefore, every 2008 and later machine, you can use this. However, it requires you to do a reboot to actually get it set up. Now you see the various ticks that I put up there, things like special pull, false IRQL checking, pull tracking, that kind of stuff. What it will do is that it's actually meant to detect drivers that are badly programmed. And then if something goes wrong, the moment you put that onto your system, sometimes the system can't even boot up because there's some driver during your boot up that actually kills it. All right? It causes corruption in other drivers' memory. So those drivers, the moment you turn on special pull, will automatically get caught in a bug check and blue screen the whole machine right from the start. Okay. Yeah, you have to go back to last known good and all that to get it back. So why would you use this? Now, in the past, I used to tell people that you use this thing every time you take shipment of a new set of PCs. Doesn't matter which one you got it from, because last time, every manufacturer out there was really bad at writing drivers. Okay? Well, they always get it from the cheapest guy, right? And the cheapest guy doesn't know how to write drivers. So what you get is you end up with this wonderful situation where you buy 5 machines, or you take shipment of 5 machines from HP, for example, and then you don't notice there's actually anything wrong. You do get occasional blue screens, but then you don't notice it, so you just keep taking shipment. If you have one of this, what I used to tell people was, run this thing first on the first few machines you got, and see if it starts failing. If you start getting blue screen, you tell HP, I refuse to take shipment of any more machines until you fix that problem. Now, because it impacts sales, you're going to get much faster response than after you've already gotten 1,000 machines and all of them are failing in the same way. All right? Okay. But nowadays, you don't have that problem. Why? because in order for Microsoft to verify a driver, to put a driver with a logo, to allow you to load it nowadays in 64-bit Windows, we force all of that on them. And that's one of the reasons why you got so much less blue screens in Windows nowadays. It's not because of anything the driver manufacturers have done, it's because we force them to be better by forcing them to actually do their work, right? Okay, so what are the 4 major areas that we always look at for systems? I think you know what they are. They're actually highlighted up there in your resource monitor, right? CPU, RAM, disk, and network. Now, let's talk about some of the issues that you usually get. Number 1, crashes and hangs are usually due to memory, driver, and so on. So those are the main ones that cause crashes. Why? Because if your disk is slow, it usually doesn't cause a crash. That's the standard answer. This is usually a majority of performance issues. Most of the performance issues you're going to get comes from the disk, right? Network retransmits inadequate buffers are a major issue in VMs. This is highlighted actually in a few places. It's just that it's not well known in the public, all right? So we'll talk about that in one of my case studies. Okay, on the bright side, we have very little CPU issues nowadays. You can thank Intel and AMD for that, all right? Ever since, 6 years ago, the CPUs have been so fast, none of the other devices on your system can keep up to it. Therefore, it's not a problem anymore, right? It may come back in the next 2 years or so because they're having something new called NVMe disk, which are basically disks that are tied to the PCI bus. Storage that's tied to the PCI bus, which is a heck lot faster. It's about 10 times to 20 times faster than normal disk. So that may start causing some other issues to show up. Well, we'll see it when we get to it. Okay. So the major problem classification is how you actually think about what you're trying to do, right? First thing is you say, look, if I get a kernel issue that crashes, the kernel crashes, it's always a blue screen, your machine is going to go down. The only way you're going to get the result or the cause of it is to get the crash dump and analyze the crash dump, at which point you know what happened. If you get a hang, you basically, hang meaning you say the system doesn't respond, right? You have to force a crash so that we can troubleshoot for you exactly what caused the hang. Without that information, we will never be able to tell you what caused the hang. We can only tell you that, yeah, it hung. Sorry, reboot the thing and try again. Okay. To force a crash, you do things like injecting NMI into your motherboard. All right. So all VMs has the ability, for example, in Hyper-V, you do a debug-vm command minus inject non-maskable interrupt. It will force the VM to get an NMI. The other thing you need to do is you have to set up the registry key first to say that when I get an NMI, I will do a crash dump. So every VM has to have that done. Okay. Then the last thing, of course, is if you have got a leak or a corruption of performance. Now, what's the difference between a leak or a corruption? The answer is this. If it's something that dies after a while, for example, the thing works fine, and then like clockwork, within a week, 2 weeks, the whole thing just crashes, correct, or dies, that's usually a leak. That means somewhere in there, somebody's using a whole lot more memory or a whole lot more some resource, and then eventually it gets to a point where it's too much and the whole system just goes down, right? And if it goes like clockwork, and the joke I always say is that if the leak is too fast, you will never get it within a few hours. Because if you get it in a few hours, the developer would have done some work to fix it because they would have seen it. If it takes longer than that, if it takes 6 months before it manifests, you'll never see it again. Why? Because most of us reboot our machines before that. Okay? So it's the one in between, somewhere between a week to about 4 weeks or 5 weeks. It's the ones that we actually start seeing this information, things going down and getting into trouble. All right, so let's start off with the first case study. Okay? Network retransmits. So what does this mean? Now, if you think back to how TCP works, not UDP here, TCP itself, right? The way TCP works is that every packet that you send out to somebody, there's an acknowledgement sent back, correct? The packets do not necessarily get there in order. You may send them in order, but the receiver may not necessarily get them in order, right? And then what they're supposed to do is they're supposed to acknowledge everything. So you could have 10 packets that were sent, then you acknowledge 9 of them. The last packet that you did not acknowledge will eventually time out. All right? Once enough of other packets have been sent, then what happens is that we'll do a retransmit. That means we will actually go in and then transmit the thing again, that particular packet. So that's recorded in Windows as a network retransmit one packet. The problem with a network retransmit is that it doesn't just transmit one packet over. It transmits everything from that packet onwards. So you may have, let's say for example, you had 5 packets that were sent out, and then you never receive an acknowledgement for packet number 2. You may have gone on after that to 6, 7, 8, 9, and 10. The moment they had to retransmit 2, the TCP protocol specifies that they have to retransmit 2, 3, 4, 5, all the way down again. They can't just retransmit 2 and then the rest that they've acknowledged. It's the way TCP works, and that causes a lot of issues. So what do you look for it? Okay, so this is a real perfmon log that I got from a customer. I've already sanitized it so you will know which customer it was. But here it is, performance monitor, and here's my log, and oh, really? Okay, I have to switch the screen, huh? Okay, hold on. Okay, here it goes. Right, there you are. So can you see the thing now? All right, so this here is basically taken from my perfmon log up here, which I then drag across, and there you go, and just say okay here. So what you're looking for is actually up in here under the network interface. You would think it's in the network interface, but it's not, because it's a TCP thing. You have to look under TCP v4, and under your TCP v4, can you see that there is a connection failure as well as the other item here, which is your segments retransmitted per second. Now, I can't give you a definite threshold, but what I can say for this particular customer is that if you look at his segments retransmitted, he basically had approximately 19, well, on average 20 segments that were retransmitted per second. That means there were 20 packets that were lost and he had to retransmit them. All right, so you think, oh, that's nothing. Well, I'll say it this way. If you're on the internet, that's fine. Because on the internet, I assume packets are being lost all the time. However, this is a SQL server, which is only accessed from internal. All right? So in that scenario, this is not good. In other words, your SQL server is losing packets back and forth as things are going through. And therefore, what happens here is that even though you may have a gigabit network, you actually have to retransmit parts of it over and over again. And that's slow. All right? And then you think, well, that's just small thing there, but what about connection failures? Now, connection failures only have a problem when they are, it's a steadily increasing number because it never goes back to 0 until you reboot the machine. So what you look for, in this case, is in 1 hour. The start time to the end time, if you look at it, is about an hour. You're looking at how many TCP connection failures occurred in this machine within that 1 hour. So I always joke about this particular one. Why? Because if you look at it right now, it looks like one big number up there, and you go, oh, well, there's no problem with it, right? There's nothing wrong with that number. So why would you complain? So what I show people is, here's the fun fact, right? This is what you tell your bosses. Okay, if your boss comes to you and say, I got a problem, your answer will always be, no problem. See, it's a straight line. See that? That's not a problem at all, okay? However, if you want to buy new hardware, this is what you tell your boss, okay? You go to your boss and then you say, let me go pull out the graph scale. So it is 300,000. I think the minimum is, if I can read the number properly, it's 328, okay. So the minimum is 328,000, and the maximum I'm going to put down there is 328, well, 329,000. Okay. And then you look at it and go, oh, well, that doesn't look like anything bad. Why? Because I scaled it. So now if I scale the whole thing again, but I put a scale down there of 1. See? This is what you tell your boss, right? Now you look at the number and go, oh, look, it's going up, right? Hey, boss, we need to buy new machines. Okay? All right? So now, the joke I'm saying here is because that's what the finance industry does to all of us. They show you stocks numbers and then they show the big jumps, right? But if you look at the scale, it's actually a very tiny jump. It's less than 1% anyway, all right, if you go to a scale of 0 at the bottom. So that's kind of what you can see here. If you look at the numbers between minimum and maximum, what they're saying is that in that 1 hour, they lost about, let me see, 120 connections. That's about one connection every 30 seconds is being lost. Okay? So these are little things that you think, well, it's not a problem, maybe, maybe not. Okay? Now, what I always tell people is, go look at your various VM hypervisors, because the people who do the VMs, they are aware of it. It doesn't mean that they're going to help you, but they are really aware of it. Why? Because I'll just show it here. VMware, network, buffer, packet loss, Windows. And observe here. See that? Known issue. And actually, most people are not aware of it because you don't actually hear of it. And they tell you here, you get a large packet loss at the guest operating system level at the VMX Net 3, which is actually the main adapter that almost everybody uses. All right? And if you go down and you look at it, it tells you the resolution. If you look at it carefully, it tells you you're supposed to change the receive buffer size. Because by default, the receive buffer is too small, when you send a lot of network traffic into the virtual machine just drops packets like crazy. And that is the result of what you saw, okay? When things are losing packets. But not all the time. They will only lose it whenever there's a high network usage, which is exactly when you want the network to perform well, right? So that's one problem, okay? So I hope this was great for you guys. At least you get to see something here. Okay. So back up to the slides. So when you get into this particular problem with the network retransmits, what do? First off, check your network buffers and retransmits, all right? Make sure they are not retransmitting a lot. Now, people ask me, is there a threshold that you look for? The answer I can't give you is because it depends on whether you're on internal or external. If your machine is internal, that means it doesn't correspond to anybody outside, right? It only goes internally. Then I would expect it to never have more than 1 or 2 packets lost per second. If it's more than that, it means you're going to have a bit of trouble. Right? On the other hand, if you're on the internet and you're communicating on the internet, I can't give you a number because it depends on how bad your internet is. All right? The next thing here is you must always check from the sender. You cannot check from the receiver. Why? Because the receiver never got a packet anyway. All right? So he shows nothing wrong. Right? You have to always check from the guy who's sending stuff out to see if he's resending or not. Right? So that's one big issue that I've seen in quite a lot of VMs that we have today. From a certain vendor, which I shall not name. Okay. Now, the next thing you can do is what we do, a continuous black box recording. So this is something where we say, hey, I have got some issues in my environment, all right? Machines are crashing, but I don't know why they're crashing. So the problem here is that a lot of things are actually recorded in the memory of the system, and then eventually we write it out into the event logs or in the various places in the system. But they don't get written out immediately. So if something goes wrong, the system bug checks, that means it blue screens, you will only get the point up to the last part where it's saved onto the disk, because the rest of the other stuff is gone from the memory. However, think back to how we do stuff in the memory. When we do a bug check, we take the kernel memory, for example, and then we dump it into the disk. So the idea here is if you already have the dump file, you can extract various things from your dump file to actually be able to work out what happened up to the very last millisecond before the whole thing bug checked. And therefore, it gives you an idea what exactly happened. We joked about it because that's exactly what the airline industry uses. How do they tell that the plane went down or what happened? It's because they are using the black box that always records everything and is in a loop. At the end of it, we actually grab the information out of that. And we say, yeah, that's what happened in the last 5 seconds before this thing went off. Right? So that's exactly what we are doing here. So let me now show you. What I'll do is basically you take your WPA, WPR recordings that you make, and then just because you put it all into the memory, when you get a bug check, a blue screen, you save the dump file. The dump file that you then save, you'll be able to extract. See the last command that I put down there? Bang, that means exclamation mark WMI trace.log save. that will automatically save up the log that you have, okay? So now, let's kind of show you again what I'm talking about here. So you see this particular stuff. Let me see if I can get that too. Ugh, it's a bit hard to read the key, okay? Here it is. Let me just close that. All right. So what I did was I went to another, by the way, these are all Azure VMs. Okay. What I did was I took the Azure VM that was running, and then I made the VM crash. All right. I'm sure somebody is not happy with me up in Azure land because I've just made their stuff crash. Where is the? Hold on, sorry, I can't find the. Where is it? Somewhere over there. Yeah, it's really tiny over there. Yep. Okay, here it is. Okay. So what I did with this guy was I made it crash. And how do you do that? Basically, I just use a little command from sysinternals to force a crash. But before I did that, what I did was you go into various things. So this is the event log, okay? So you go into event log, and then you pull out, for example, I want to know the WMI. What were the WMI calls that were made up to the point where it crashed, all right? You go into WMI, then you open up this part here. You go View, Show, Analytic, and Trace Logs, okay? And debug logs. Then you go in here, you see this guy here. That's a WMI trace log. That tells you every single WMI command that was done on the system up to the point where we save it, all right? So you right click on this thing, and then you go into the properties, and you just say, enable this log, all right? At which point, it will start saving all of this in the memory buffers of the system, okay? So what I did 2 days ago was I did all this stuff here, recorded that, and then I used the Windows Performance Recorder, where I say, well, here's the recorder, record this stuff for me. I want to do a first level triage. I want you to record my CPU, my disk, and my pool usage, that's the memory stuff, and I also want you to then do some custom measurements. So these custom measurements here, by the way, there's one profile that's given to you on every box the moment you install it, so you can see that custom here. Sample general profile for large servers. So you can just use that guy, and that will allow you to collect data that's appropriate for this thing. Then what you do next is you just start the thing. So notice here that I put it in, I said, well, log to the memory instead of logging to the disk. In this particular scenario, if you don't specify how much memory you want to log, it will always use 20%. It will use a maximum of 20% of your system memory to actually start logging. So you can see it here. It starts the log, and then it's doing stuff. All right? So what I then did was I just said, okay, now that you got something working, logging, and hopefully the error will occur straight away. So, well, here, let me see, where's my mouse? Yep, and what you do is you run something called not my fault in sysinternals. So that's a Rasonovich tool. Okay, let me just go find it. I think I dump it in the C drive under temp, if I remember. And you should see the whole sysinternal set of stuff here. And not my fault is here. See that? Not my fault, 64-bit, etc. Right click, and then do a run. And then yep, okay, and just say crash. The moment you do that, it crashes the VM. And obviously, yeah, I can't do anything now, all right? What happens in Azure is that it's actually crashed, all right? You don't really see it, but it actually has crashed. And unfortunately, now I need to find the mouse. Okay. There you go. As I said, it's already crashed. Okay, so that was the other VM that I crashed. So what I did 2 days ago was after it crashed, I grabbed the dump file on the next reboot. So that's the dump file here. See that? Memory.dmp. Hold on, let me see if I can just switch the screen over for myself. Nah, I can't do it from that particular guy. Okay, here. So what you do is you run a debugger, Then you say open the crash dump, all right, the crash dump of whatever that crashed. Pull out the dump file, right? In this case, that's the guy. It will then start its loading. And note, you must do the symbols and everything first because that's what's going to happen here. It's actually going out, trying to download symbols and everything you can see at the bottom. It takes a while, all right? Usually a few minutes to actually grab stuff, especially if it's a new machine. Okay, and then what you can do is you can do a bang, that means exclamation mark, analyze minus V. That will tell you within the debugger, based on its heuristics, what it thinks went wrong on the system. You don't have to do it in this case because all it'll tell you is you got an IRQL failure in notmyfault.sys. Okay, because that's the the driver that actually caused the crash. All right, so that's why I'm not going to bother. All right, what I'm trying to show you is this part here. So you do an exclamation mark WMI trace dot str dump. So that tells you a list of all the items in your system that were actually logging to memory at a point when the thing failed. What we want, for example, is the WMI stuff. The WMI stuff is up there, is in, if you look at the third column, it's 0x0b, that's WMI. Now if I also want the event log, the event logs are all there. See that, the application log, the system log. There is also a security log if I go up a bit, so you can actually see it. And all the other stuff that I've done with WPR, Windows Performance Recorder, will also be there. Okay, let me try and make this thing larger so you can actually see it. Can you see it now? Can you see that the security log is up there, the event security log? And then for all those things that you're running in Azure, all the VMs that you're running in Azure, they actually put two separate logs happening. So there's one called RT events, and there's one called GA events. Okay, the fourth guy or the fifth guy from the top, and 6 from the bottom. So those two are actually recorded in, and that's used by the Windows Azure agent to actually report what's happening in your VM. So whenever you do diagnostics and everything in Azure, those things show up in there. So you can see here, there's 2 WPR stuff. So the 2 WPR stuff is basically the ones that control the exact information that Windows Performance Recorder is actually recording. So you can, at this point, now that I got that information, I can dump it all out. Right? In the same way, if I want to dump out the WMI, I just do the dump of the WMI. So WMI is 0x0b in this particular scenario. So all you do is you just do a bang, WMI trace dot log save 0x0b, and then you put a location where you want to save it, C drive /temp WMI dot. For that, you save as an evtx file because it's basically an event log. Right? Once it gets saved, all you do is you go into the evtx file after that and you double click it, you open out an event log and you see all the events that happened right up to the point where it all crashed. Right? So you do the same thing again with the WPA stuff. It's a heck of a bit slow here. Okay. By the way, when you're saving this, you must save on a machine that has symbols all set up and is on the internet. The reason is because it's going out to grab all this information so that it can correlate. If not, what you get is a event log with numbers, but without the corresponding detail that you want. All right? Okay, so just to prove that I know what I'm talking about here, let me get to my mouse again. Here you are. So all I'm going to do now is I'm going to go into C drive. Temp, and you should see this WMI that I just saved here. Right? Double click it, and it opens up your event log, and you will now see exactly the event log that came from that machine up to the point it crashed. See that? It actually pulls out and tells you, yep, that's the particular event log that you're interested in. Here's the event, and it actually tells you exactly what command was being run. So for example, somebody was doing a command on checking where the domain is, whatever that domain is for that machine, and then the client machine name was that. The user, this one in this case it didn't say who, but normally they'll tell you who the user was who initiated it, as well as the process ID and so on. So with that, it gives you the information you need to troubleshoot exactly what happened in your WMI, right? various things that's been calling a system. Okay, so any questions on this part? Nope. All right. Let's go back to the slides. And so that's your WMI, saving it. Next thing we have, next case study, is phantom CPU issue. So this was interesting because that happened a couple of years back, I remember. And by the way, this flummoxed a whole lot of people at Microsoft. As in, you got a whole lot of people looking at it going, it can't be, that's not possible, all right? But it went like this. So I'll give you the story. We had a HP notebook. It was running very, very slow. Please note, I'm not intentionally banging on HP here, okay? Every vendor out there has exactly the same issue in most cases. So what happened was, it was so slow, we couldn't figure out why. So we just went, all right, looking at all the stuff, and then we say, hey, it was using 74% CPU constantly, all right? Then we went, okay, we checked WPA, checked other stuff, system was using it. What the heck is that? Nothing, okay? Couldn't trace it. We unplugged all the devices that we could find. Nothing, still exactly equally as slow. Then we realized that when we rebooted the machine, even the BIOS screen was slow. Okay, remember the BIOS screen, okay? When you go into the BIOS, it takes like 5 seconds to even refresh the BIOS. Okay, so he was like, hey man, there's something wrong straight away. And then we say, oh, I'll change the memory, still slow. We finally figure out that when we change the power adapter, everything went fine. Seriously, it was the power adapter. Totally unbelievable. That's why I said, the moral of the story here is, you may think you know everything, and something comes out that makes it totally different from what you think it happened. Right? And that's exactly what happened in our scenario. All right? When you have to look at something sometimes, whatever seems impossible, at the end, that could be the only case. And the only reason we figured it out was because some guy had a smart idea to say, hey, what happens when I unplug the power? And then everything went back. All right? Then we plug in a new power adapter. Hey, everything is fine. Plug back the old one, went up to CPU, slow again. That's when we figured out it was the power adapter. All right? Like I said, it's up here. See? Because all the tools out there wouldn't have told you that this was a problem. All right. So last case study here is NUMA. So NUMA is basically what we call non-uniform memory access. So that basically happens in every system, the newer ones now, ever since Intel came up with the Core i series. All right? So prior to that, Intel's platform was all uniform memory access. That means all your memory was put in one bank, and no matter which CPU was accessing it, it was equally slow. Okay? Then they came out with something called NUMA, where some memory is situated very closely to your CPU, and another CPU would have some memory situated closely to it. So in that scenario, depending on which one you are, you'll be fast in certain areas and slow in certain areas. So you can actually see here, up there, you run a tool called Core Info from sysinternal, and it will tell you what is the approximate cross-NUMA latency that you are achieving. Now, this is run from a VM, that's why from a machine with Hyper-V already installed, that's why it's wrong. If you look carefully at that number at the top corner, you see 0001. What it means is that if I am in memory, CPU 0, I'm trying to access memory from the bank 0, I should get 1.0. That means that's the baseline number. By right, if I'm on CPU 1 and trying to access memory on CPU 1, I should not get 1.4, I should get 1.0 also, because it should be exactly the same speed for me. Then what you're looking for is the other two, the 01 to 00, 00 to 01. That one is the slowness that you're looking for. So in this particular machine, for example, it's 50% slower when it has to access memory out of its boundary, or 30% slower depending on which one. And that causes performance issues. Now, here's the bad news. For NUMA, the OS may be able to handle it. It's unimportant. The OS handles it, it's great, but the application must be able to handle it. Because if the application doesn't handle it, it actually doesn't solve any problem, because the application will still try to run something and then go grab the memory from there, because he doesn't know anything about NUMA, right? So he just grab memory from everywhere. So from Microsoft's part of it, basically most of our big applications have already been NUMA ready. SQL Server 2005 and later, Exchange Server 2007 and later, we've already made it. IIS was the holdout. In other words, IIS 8 was the first version of IIS that was NUMA aware. And for those guys who know, IIS 8 is 2012. In other words, IIS 7 is not. So 208R2, 208 are not. So what it means is, you'll find this quite commonly. If you try to run a 32-bit memory pool in IIS 7, that means in Windows Server 2008, it's actually faster than running a 64-bit memory pool. But then you go to 2012 and suddenly it doesn't have that much difference anymore. The reason is because they are NUMA aware. And why 32-bit seems to run faster is because when you're not NUMA aware, 32-bit is limited to 4 gig. The chance of you crossing the NUMA threshold at 4 gig is very low because it all tends to be in one place because it's tiny, right? On the other hand, with 64-bit, you can go up to a couple of terabytes, and therefore you can actually exceed the NUMA boundary really fast. Okay? So, what you need to do is check with your application vendor and see if they have a patch or anything that solves this problem. All right? First thing you do, run that part, see how bad it is in your environment. If it's less than 10%, which some of the newer chipsets are, the newer chipsets are 10 to 20%, then you won't have so much of a problem. This particular machine that I ran it on is old. It's about 5 years old, and that's why you can see the numbers coming out that way. All right. So now, I'm going to show you the WPA stuff. So for this, I need to see if I can switch the screen. It's a bit hard for me to present through both sides. Let me see if I can do it. Duplicate. Okay. Yep, you should now see me. And let's see if this guy shows up. Yay. All right. Yes, it's showing up. Cool. That's a heck of a lot easier for me to do it now. All right. So on this PC, I've kept one ETL file. So the ETL file is basically what you get when you run that whole thing, the WPA part. After it's all saved, it goes in and becomes an ETL file. So this was my machine a couple of years ago, and I have to show it from this machine because newer machines don't have this problem. And I'll show you what the problem is. Okay, so this is what it looks like here when you're using Performance Analyzer. Brings the thing up, shows you all the various things that you're collecting. All right. So first thing you do before you actually go in and check stuff, please go in and look at the trace information. Okay, so I'm going to load symbols here, and then I'm going to put trace information here regarding your system. Why do you want to see that? It's because you want to know, for example, when was this recorded? How long did I record it? About 2 minutes, plus minus, yeah, about 2 minutes. And you can actually see no lost buffers, no lost events, which is great. That means nothing got lost in between. Okay, the next thing you can check here is it will tell you about the exact OS that I recorded all this stuff on. So this was a Fujitsu T-Series BIOS of 2008, wow, okay. And it was running this 2 OS. Does anybody know which OS is this? Come on, you guys should know by now. 7601 Windows Server, or Windows 7, 2008 R2 or Windows 7. The 01 means it's a SP1. 7600 was without SP1. Okay, and then if you look down here, you can see that, yeah, it was running Windows 7 Enterprise, and you can see that I had 2 CPUs, exactly what CPUs they were, what's the CPU speed, how much memory I had on the system, and so on. What are other stuff? It also tells you what the display is on the system. For example, this is using an Intel motherboard with an Intel chipset, and your disk. So you can see in this particular system, I have 2 disks. One of them is an SSD, OCZ Vertex Turbo. The other one, when they say Samsung HM160JC whatever, is a standard hard disk. All right. Now, what are you looking for? It's all this stuff here. See this? When you see this stuff, it tells you, for example, number 1, if you see any number that doesn't end in a whole lot of zeros here, it means your disk is not aligned properly. This alignment automatically works out to be something with a lot of zeros at the back, at least 4 to 5 minimum. The reason is because if you're aligned nicely, it will work out to a hexadecimal number. If you don't have a whole lot of zeros, you end up with something like 1, something, or whatever, you are not aligned. Now, that's no longer a problem in most cases for most people, unless you happen to be taking a partition from Windows 2003 and reusing it. If you have rebooted and reinstalled all that, you shouldn't have a problem anymore. Okay, so in this case, great, no alignment issues. Other stuff, it will tell you exactly what network cards you have, what the IP addresses were of the network card, as well as all the various settings on the network cards of that particular system. right? It also tells you which services were there and what was the state they were in, whether they were started or stopped at the point that I was taking the trace. All right? Okay, so now let's say the situation here is that this system was slow and you want to figure out why is it slow. So what do? You go in and you look at the four main things that I told you before: CPU, RAM, and so on and so forth. So if you look at CPU, so I'll show you the graph here for CPU. In this case, what I'm looking at for the graph is I'm looking at the CPU usage, utilization. Notice that, well, it seems that maybe something is using a lot of CPU, maybe not. But what you also want to see is to actually see what is the CPU usage by process. So if you look at this guy here, it tells you that this is exactly what the overall CPU usage is like. Now, remember, I have two CPUs. So the maximum I'll ever have is 200%. What this means is that I'm actually not CPU bound. Because even at the highest peak, it was 150%. 70 plus on both sides. And in most of the environment here, it was less than 50% as it was going through. See that? So that means CPU itself is not a problem. Because if it was, it would have pushed the overall numbers a lot higher. So therefore, we can rule out CPU. Next thing you want to say is, how about memory? Do you have enough memory? Correct? So again, you look at the check here, and then you look at the various memory numbers. In this case, not much though. I only recorded the hard faults on this system. But if I had recorded in perfmon or something else, you can actually see that it doesn't have a lot. Okay, so I'm going to close off this CPU counter and that CPU counter. So, right. Okay, so if you just look at memory now, you'll find that, hey, there's hard faults means whatever that you're actually sending down to the hard disk. Okay, that is a primary indicator of either memory being low or your hard disk being slow. Because either of those two will cause this particular issue where you got lots of hard faults. If you see the number when it finally pops up, okay, you will see that I've got quite a high number of hard faults per second, which should not happen, because in theory you should have a lot less than that. Oh man, this thing is really, really slow. Okay, never mind, I think we'll just leave it alone while it's doing that. So, if I were to then, now that I know approximately where it is, if I were to then look at storage, okay, so first off, if I look at this particular chart here, it gives me my utilization by disk. That means the disk itself, overall, how much is being used. Can you see that? It's pretty clear it's a storage problem. Your disk is hammered 100% at certain points. That means what they're saying is that your disk has no time to breathe. It's just being hammered, asking to resolve requests. Okay? Now this thing doesn't tell you what files, this part here doesn't tell you what files are being accessed. It just tells you that these are the IOs that were made to the disk, and it was made to disk number 1 or disk number 0. All right? So you can see here that in this case, if you look at the lines, it shows up very clearly that that particular disk is the one that has a whole lot of usage. The other disk has almost 0 usage. So it's disk number 0 that has the most amount of usage, and it's coming from a process called system process ID number 4. So when you see these numbers, you then go back and you look and you say, all right, who is process ID number 4? And that system. And you go, oh, well, that can't be a problem. Something else is calling it. So at this stage, what I always do is I then pull out who is the one issuing the most requests, and you do that by process. That means you go to counts by process, pull that one out, and it will actually show you which process uses the most CPU. See that? I mean the most disk. So system issued a total of 231 microseconds, 231 million microseconds. It's 231 seconds worth. Now remember, this trace was what? 2 minutes? Okay, that means it's actually using the disk like crazy, correct? Because it's using the disk so much. And then same thing here, Outlook. Yes, now we found the culprit. These two are the one using the most of the disk. Straight away, right? And then you go, yeah, that's first level analysis. It tells you who's the culprit, which app. Now, other things, because this particular disk is not a SSD, you want to check, is it possible that the disk may be fragmented? You need to do some defragmentation and so on. How would you know that? Basically, you go in and you look at what Outlook is actually issuing. So you see here, Outlook is issuing stuff, right? there's a part here where we say a disk offset. So the disk offset graph shows you where on the disk you're actually reading stuff. So the bottom of the graph is the start of the disk, the top of the graph is the end of that disk. So each dot here tells you exactly where you're grabbing the stuff from the disk. Now if you look at everything, it looks fine. How do you know whether or not it is actually a problem? Is when you start splitting it up. See this? Okay, you go in this guy, and then you see Outlook is using this, right? You right click on it, and you say filter to selection, means that up there it will only show you everything that Outlook is using. Now, tell me, is that fragmented or not? Probably yes, because it's jumping all over from the front of the disk all the way to the back of the disk. Fragmented. Cool? Okay. So you can see just from one simple trace, I can gather all this information. This is second level analysis now. I can tell you that you have a disk problem, and that disk, you probably want to do some work against it, all right, to defragment the disk. What are other stuff here? I can then say, look, these are all just reads, all right. So if you pick any of this, it will then highlight for you exactly which one it was. See that? And if you need to know more information, we usually have the ability to then pull up from here exactly which process at what time. So the time here when it says 38 seconds means it's 38 seconds from the start of the trace. Exactly what happened in it. All right? So now we go, all right, we know it's Outlook. How do I know exactly what this Outlook is using? Actually, you can, because all you need to do is go in and you look at the other stuff here, for example. Okay. Right, so you see here, it tells you that there were a whole lot of reads, a whole lot of writes, and so on. When you pull out, it tells you exactly which app, and it tells you these were the times for each of them. Right? How long it took to read this one, for example, 282 microseconds, 82,000, that's 282 milliseconds. Now, please note, we have always talked about performance as anything more than, what, 20 milliseconds was considered slow. This thing is 10 times that. All right, it's that slow. You can see how slow the system was at the time I was reading it. Okay. Now, if I want to pull out, say, for example, the path name, the process, the path name, and so on, it will then tell you exactly for this particular guy. See that? See all the marks here? It means that at that point, okay, that's exactly what he was doing. He was reading all of that. All right? And where it was. So you can actually see from here straight away, majority of the problem has to do with Outlook. Search indexer has a very little bit. And then the next one underneath, MSMPENG. Does anybody know what is that? Windows Defender. Okay, Windows Defender is doing virus scanning. You can see it's so small points of it. It's actually scanning the stuff. All right? And then after that comes all the rest. So straight away you can tell that this is an Outlook problem. The Outlook is reading disk, and the disk that he's reading comes from different places. That's why it's fragmented and it's taking so long, because the disk has to jump all over the place to read it. How about other stuff here? Then you want to know, right, well, now that I know exactly which one, how about telling me which files they were reading? There you go. That's the file. Okay, and you can see majority of it comes from one file, outlook.ost. Now, practically speaking, now that you figured this out, what can you actually do on the system? Not much, actually. Seriously, the system is like that, right? So the basic thing you can do in this system is, well, if the boss is willing, switch it to SSD, in which case the performance will be much better. If not, then you defragment the disk so that you actually have it all down to one spot instead of multiple places. And see all these files here? You probably want to tell the guy, hey, you might not want to have so many archive files around in your Outlook, because that makes your Outlook slower when it starts. You see what I'm trying to say now? Okay. So with just one simple trace, I can actually go in there and tell you what's happening inside the system. And with that, we can prescribe for you what is good. So note, as a recap here, based on whatever that I've just talked about, you can now see, all right, from our side, basically, when you look at, I'm going back up again, okay, back to the front. So when you look at this guy here, all right, what you are looking for, basically, is what is the problem And that problem defines a certain tool you use. Because if you see the problem is a crash, kernel problem, whatever, it's going to be Windows Debugger or stuff like it to actually troubleshoot the parts. If you see a performance issue, it will always tend to be perfmon or WPA. You use perfmon as a broad-based thing, record over a few days, few weeks, whatever, and then you use WPA to go into specific areas. All right? Okay, that ends my whole presentation. Does anybody have any questions? Yes? Yes, if you use WPA, you can. So there's two ways you can actually trace that. The newer task managers actually give you that ability. So the newer task managers will actually show you exactly which process was starting which service. See this? So if I go in and look for SVC host here, all right, it will actually tell me which process was actually running which SVC host. Okay, see that? All of this here, it tells you exactly which one it was, all right? And that's the process ID of the specific one that I'm interested in, all right? The other thing is, if you go in here and you look under SVC host, you will now see this stuff, and then you go, oh, well, I can't tell. The other way is you run your command prompt, and you run task list /SVC. Okay, let me pull it up so you can actually see it. See all the services that are running? 884 was CDP user service, one sync service. 2672 was state depository, tile data, and so on. So it actually tells you that. If you go back into this guy directly, it will also tell you based on the process itself. So if I pull out one of this SVC host, you can actually see based on the files that he's reading, correct, which one it is. And if you want to know which one, you go in under the CPU part instead of looking under the storage part. You go under the CPU part of it, and then you pull out, see this part here where it says processors, lifetimes, and so on. If I pull out this one, you will see straight away, come on, processors, lifetime, okay? You will then be able to see for each one, well, there's not much SVC host to show you, but for each SVC host, you can actually drill down and it'll tell you exactly what were the DLLs that were loaded. So the DLLs that were loaded will tell you exactly which service it was, because that particular host is loading those DLLs, which means that they are the ones that actually are in there, okay? So there are multiple ways you can find it. The easiest, like I said, is going straight through your command prompt, because your command prompt already has the info, right, down here. That shows you exactly which service is running. And if you're the newer versions, Task Manager will show it to you better. Other questions? /SVC, that means show me all the services. Task list itself is a command line version of Task Manager. Then you say /SVC means show me only the services. Okay.
Sorry, various laptops I've had, I've put them into PowerSave and brought them back out, and then had Wi-Fi problems.
Mm-hmm.
How do you troubleshoot that?
WPA.
I mean, obviously it updates drivers and stuff like that,
Yeah,
but
it is. But you want to know which driver and what's causing it in most cases. WPA gives you that information because if you go into Windows Performance Recorder, all right, so if you, let me see this part here, Windows Performance Recorder, come on, there you go. So when you run Windows Performance Recorder, remember all this stuff here? There's a new scenario analysis that gives you all this stuff, all right? Audio glitches, video glitches, Internet Explorer, Edge browser, and under resource analysis, there's one that tells you power usage. You pull that one on, you will be able to actually get all the power usage and see what happened to a driver. Because what you're looking for is that when this thing initiates, the driver is put into a lower power mode, it will do that. Now, practically, there are things you can do to resolve it, because some cases, if you go into your device manager, you can go into various drivers and you can say that for this particular driver, do not allow the computer to turn it on. Okay, that tends to solve the problem for most people. All right, doesn't mean that you solve for everyone, but in truth, you should be going to the manufacturer and squeezing them for a better driver. No. The reason why there isn't is because there are too many drivers and each driver has a different setting. There is a command line option that you can run on some of them because you can download a tool called Device Manager. There's a command line version of this tool. That means of this whole device manager tool. And then you can use that to enable, disable, and change things in there from command line. All right, not that it's great, but yeah. Okay. Other questions? Yep. Uh-huh.
Do you use process monitor a lot, and in which cases do you normally use that?
I'll say it this way. If you don't want to go in-depth into WPA, process monitor is easier because it gives you all the information up front and it logs everything. Correct. Process monitor is basically like WPA without the internal parts, without the microsecond stuff. It actually grabs all the processes as they're running and what they're doing. Okay, so it's combined. It used to be to have a separate registry monitor, file monitor, and all that. So they're all combined now into one. So it tells you that this process, when it starts, what files it's actually picking and so on. All right, yeah. So yes, you can use that one too. I didn't show it here because, like I said, I was just showing more of the in-depth ones in WPA. Mm-hmm. Okay, all right. Question? Yeah.
How about the codes that we write, that we, like .NET applications that we host in IS8?
Yeah.
Does it affect it, or it's just the process of the
It
IS?
basically chooses, so for example, if it loads your application pool, and your application pool is asking for memory, it will try to make sure that the memory it gets is near to it. It will not cross the NOMA boundary to get memory from elsewhere.
Okay, so as far as the codes, we don't have to do anything?
No.
So it's the problem of the IS?
Yeah.
Okay.
Okay. Mm-hmm. Other questions? Yes? Oh. Okay. There are bits of tricks. Basically, you can do, okay, I'll explain it this way. Windows Performance Recorder has two parts. There's one part that's recording events, you know, all those events that I showed you from the event log, all the hundreds and thousands of events that appear. So that one, you can use logman. So the standard logman performance monitor thing, you can say, do a trace for me or do a capture for me and save it to a file of various things in there. But the other part of XPerf, which is the one that goes CPU per microsecond, exactly where the CPU is, those things don't exist unless you run Windows Performance Recorder. So you get half of it, but you don't get the other half if you use command line. Okay. Now, you can get a command line version of this thing. So I was showing you from the Windows Performance Recorder, right? There is a command line version of it called XPerf, and then you can just type in all the commands. But you need to install it to get that. Okay. Right. Other questions? Nope. Okay, then I think that's it all for everybody. Thank you. All right.